The first learning objective of this unit will be to identify the 6 trig functions of a right triangle. Now, before we can do that, we need to know all of the sides of a right triangle. In this case, we know 2 of the sides. They happen to be the legs. The legs are going to create this right triangle. So we need to figure out what is the hypotenuse, the diagonal side of the right triangle, also the longest side. And so I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. It does not matter what leg I refer to as A and which leg is B. So 9 squared plus 7 square roots of 2 squared equals c squared. Now I know 9 squared is 9 times 9. 9 times 9 is 81. I'm going to write this out because I see a lot of students making the simple error here. And I'm going to point out where they make the simple error. The first thing is we're going to multiply it. And we're going to start by multiplying values that are in the same form. So 7 and 7 don't have square roots. 7 times 7 is 49. Now the square root of 2 times the square root of 2. How do we do that? Well, we're going to multiply the values inside of the square root. 2 times 2 is 4. Now I know the square root of 4 is simply 2. It's not the square root of 2, it's simply 2. And too often yesterday people wanted to also put a square root on that value. Now 2 times 49 is 98, and now you're going to grab your calculator for me and you are going to add 81 plus 98 quickly on your calculator. 81 plus 98, we get 179. The second learning objective, the second task of this is to make sure that everything's in simplified and in proper mathematical form. So I'm going to find 175, which is right here, and I'm going to work backwards. We need to find the largest perfect square that divides into this if possible. 1 is never actually going to help us reduce something. So I'm taking 179 and I'm going to divide it by each one of these numbers to see, do I come up with a whole number? Again, we went over this yesterday for anybody who happened to be in class. And so I'm going to go through all of these right now very quickly as I'm checking to see, can I reduce 179? How do I know if I can reduce? I know I can reduce if when I divide by a perfect square, if I end up with a whole number. And you can see that each one of these, nothing reduces down to a whole number. So I get to come up here and write 179 equals c squared. I take the square root of 179. It does not reduce. Square root of 179. Okay, my next task will be to identify the 6 trigonometric functions. So I'm going to come off to the side here, and we're going to start with the primary trig functions, sine, cosine, and tangent. As a reminder, sine, cosine, and tangent are simple directions that allow us, after an angle is chosen, which you will be told what angle to choose, after an angle is chosen, you are going to come up with a ratio that describes 2 of the 3 sides, and the 2 of the 3 sides need to be specific. The directions for sine would be opposite over hypotenuse. Now from this angle, opposite is directly across. So this is the opposite. The hypotenuse is the diagonal side or the longest side, and then the only remaining side happens to be the adjacent side. So there's adjacent, opposite, and hypotenuse of this particular angle. Okay, the directions for sine would be opposite over hypotenuse. Opposite is 7 square roots of 2 over the square root of 179. Cosine, not cos, cosine is adjacent over hypotenuse. So 9 over the square root of 179. Tangent is opposite over adjacent. Opposite over adjacent. Now let me put these into proper form. Mathematically, this is all correct. Proper form we talked about yesterday, we're going to throw this up top. So 7 square roots of 2 times the square root of 179 all over. I'm going to rewrite that number with no square root. But we're not in the final form here. I'm going to multiply. Notice there's 3 values. I'm going to multiply values that are in the correct, in the similar form. So 2 times 179 is going to be 3, I wrote that wrong. Is going to be 358. Please pick up your calculator right now, and we're going to see, can I break down 358? Now I'm going to start by actually going backwards. Let's see, can I divide it by 4? Oh, can't divide it by 4. Let's see if I can divide by 9. I know this is the backwards way that I told you, but it will tell me if I need to continue to break it down. I know that doesn't work. I don't think this is going to be broken apart, but I'm just going to try a few more here. I'm trying these perfect squares backwards, and I'm seeing right now that nothing is going into it. So I'm feeling pretty confident that I cannot break this down any further. Okay. Also, I need to check, can 7 over 179 be broken down? 7 divided by 179, I'm going to hit math fraction, enter, enter. We can see it cannot be broken down. This is my final answer. when I evaluate the sine of this angle. Let's go with cosine. Cosine, I'm going to throw this up top, so 9 square roots of 179 over 179. Again, I'm going to grab my calculator and just make sure 9 divided by 179 cannot be reduced, and we can see that it cannot be reduced. Okay, looking good. Now let's do tangent. Can 7 over 9 reduce? Now I know it can't, but if you're not great with that, you can plug it in. We can see it cannot be reduced. Y, please turn to your partner. Are you ready? Y for sine and cosine. Did I have to do all this extra work of rewriting things? But for tangent, I just had to make sure it was simplified. Turn to your partner. 10 seconds go. 10, 9, 8. Elijah hit it right away, and he was very simple with his explanation. There's no square root in the original ratio. There's no square root. I can't reduce these. We're done. Okay, now we're going to do the cosecant, the secant, and the cotangent. These are all called secondary trig functions, and they're reciprocals. We're not going to say opposite. They're reciprocals of sine, of cosine, and of tangent. So I'm going to try to teach you the fast way of doing this so that you can do the least amount of work. I'm going to come up to sine. Here was sine, right? Does everybody see this? This was the sine. And I even had it in this form. I'm going to take this and I'm going to flip it. So I'm going to write 179 over 7 square roots of 2. Now turn to your partner. Remember, some students were not here yesterday. Verbalize, what do you think you would do right now? You ready? You have 10 seconds and then I'm going to do it. Begin. What would you do to put this in proper form? I took the reciprocal. What would we do? I take that square root of 2, I throw it up top, and then I rewrite the 2 with no square root. Now I can't stop here. These are in the same form, so I have to multiply. I'm going to take 179 times 2, and I get the square root of 358 over 14. Now I've already checked. Remember up here, I already checked 358. I can't break it down with perfect squares, so I know that this is in simplified form. Let's find cosine. Okay, here is cosine. I'm going to flip it, so the square root of 179 over 9. Turn to your partner, whoever is taller. Tell your partner what's the next thing we have to do with secant. Go. What do we do? Do we have to do anything? This is what I have. Do I have to do anything? There's no square root in the bottom. I've already checked up above. The square root of 179 can't be reduced. We're done. Okay, let's go to tangent. Now tangent, I'm going to take the reciprocal. Oh, I just wrote it down wrong. Here it is. Okay, you ready? I want the shorter person between you and your partner to explain what would we do next. Ready? Begin. How do I put this in proper form? Mathematically, it's right. How do I do proper form? Nine over 14 can't be reduced, and we're done.